Okay, guys, sorry for the late post, but Mahdi's sick, so just got home from the doctor's office. All right, so let's finish up. So first off, we need to know the properties of continuous functions, which basically says that if a function, so if the function f and g are continuous at a point, let's call it C, at x equals C, then the following combinations are also continuous at that same x equals C. So basically, if f is continuous and g is continuous, then f plus g is also continuous. F minus g is also going to be continuous. Product, so f times g is also continuous at that specific point. Okay, and of course we'll do more problems in class. And then f divided by g is continuous, but remember, anytime you do division, we have to make sure that we say that g of c does not equal 0. So even though it's continuous, it can't be 0 or else this wouldn't work. Constant multiple, when you multiply the functions f or g by any number. So k times f for any number k. And then if you guys remember composition, f of g, alright, actually it has to be the other way around, I believe. So it's g of f. I don't think it really matters, but I guess we'll see through examples. And you remember what this means is that g of f of c. So if f of c is continuous, then g of whatever that is also going to be continuous. All right, this first example says, show that y equals x sine x over x squared plus 2 is continuous. Now, I'm not going to lie, the explanation is a little bit long. So first off, I'm going to show you when you graph this in the calculator or using Desmos, you get kind of like this graph. And actually, I just drew it completely wrong, but you get a graph like this. Okay? And you can see that this graph is continuous because it does keep on going on forever and ever. So the graph suggests continuity. Okay? But how do we prove it? We're going to use theorem 7 in the book, which is the whole idea of composition. Okay? So we're going to figure out a g of x and an f of x and make it look like y. And then from there, after we figured out what g of x could possibly be and what f of x could be, so that these two could be the same as y, then we're going to use the properties to kind of like defend our decision. I want to do this together in class, so I'm going to leave it just like this. If you do want to look in the textbook, this problem is directly from the textbook. It is one of the examples. Alright, number 2 says find the points of discontinuity if there are any. So if you graph this, you guys should know that cubic quadratic, quartic, linear basically, and I don't mean linear like a line, but line as well. But functions without a denominator that are just added are continuous. The reason why we know is we know that this guy is continuous. If we graph just that, you guys know that it's a little s. If we graphed just 3x, it's also continuous and it looks like a line. And if we graphed just -7, it would also be continuous and -7. So based on the properties, if each part is continuous, that means the sum of all of the parts are also continuous. Okay? And if you graph this, you know that it looks like a cubic function. I'm not going to graph it perfectly. So are there any points of discontinuity? No points of discontinuity. Discontinuity. Okay, this is a continuous function. All right, looking at this next one, we could try to graph it first. So when we graph it, we can kind of see where the points of discontinuity are. Or we can look at the denominator. Now, you don't want to do anything right now because we do need to find a common denominator, which could possibly find us a whole, so a removable discontinuity rather than just vertical asymptotes. So what I'm going to do here, I'm just going to make sure. Okay, I'm not saying that this is what you always have to do. So to get a common denominator, of course, we multiply the top and the bottom by x plus 2, x plus 2. So what ends up happening is you have 1 minus 4 times x plus 2 squared. All of that is now over x plus 2 squared. So I was just making sure that we're not able to cancel anything out. Now, what we could try is to distribute this and see if we can combine like terms and maybe factor it. So I'm just going to keep going, okay? I'm not going to assume things that I don't know. So this is going to be 1 minus 4 times x squared plus 4x plus 4 over x plus 2 squared. Keep going. This is going to be 1 minus 4x squared plus 16x plus 16. And now we can subtract. So it doesn't look like we're actually going to be able to cancel out any types of denominators, but it is a possibility in some problems. So 1 plus 16 is going to be 17, so we're left with 4x squared plus 16x plus 17. And obviously, these are not going to be the same factors. So here, what is our points of discontinuity? It's the points that make the denominator 0. So what are they? X cannot be -2. And what type of discontinuity is this? It's infinite because this is a vertical asymptote. All right, next up, same deal, right? We're going to reduce. So x plus 3 over, we factor this down, we get x minus 5, x plus 2. Nothing cancels out, so no removable discontinuity, but we do have an infinite discontinuity where at x equals 5, or x cannot equal 5, I should say, and at x cannot equal -2. So there's two ways that you can say that. The infinite discontinuity is at x equals 5, and it is at x equals -2, but we have to understand that that means that this function can never be 5 or -2. Alright, we're going to leave this one for class. This is a good one to do all of us together because there are two things that we have to watch out for here. Remember, this is a radical. So in a radical, it has to be greater than 0. So the discontinuity part is going to come from it being less than 0. And then this is the trig. It's in the denominator. We also have to take that into account. All right, now the intermediate value theorem. We've done this before, and here I'm going to actually do the example that we've done before in pre-calc first. So we're going to use the intermediate value theorem. Basically exactly what it says, intermediate value theorem. It's the value in between. All right, so what we want to show is that the polynomial function, this guy, has a 0, which means what? It means it crosses the x-intercept on the interval 0 and 1. So I want to know from 0 to 1, does this graph cross over somehow that x-intercept and cause a 0? So if you remember from last class, what we did is we basically plugged in. So at f of 0, it's going to be 0 cubed plus 2 times 0 minus 1, which gives us negative 1. So at 0, we are at negative 1. And then at 1, 1 cubed plus 2 times 1 minus 1 is going to be 1 plus 2, which is 3 minus 1, and that's 2. So at 1, we are at 2. So if you remember, because there was a change in signage, okay, from negative to positive, or it could have been the other way around, positive to negative, even without looking at the graph, I know there's a 0 between 0 and 1. And it shows right here, if I went from 0 to 1, I'd have to pass through that 0 to get through. So that's how it was in pre-calc. Okay? Now we're going to start looking at it a little bit differently. And the homework problems are going to be a better bet for you. So a function, y equals f of x, that is continuous on a closed interval, a, b. Alright, so I'm just going to draw a function here. Let's call this guy a and this guy b. And takes on every value between f of a and f of b. And these are basically like your y's. So f of a, let's call it right there. And f of b, let's call it right there. So when the x variable is a, this is f of a. When it's b, f of b is over here. And let's pretend that this graph does one of those. So in other words, what this is saying, if f of x is continuous from a to b, which it looks like it is, okay? And if f of a does not equal f of b, which f of a looks like here it's 2, and f of b it looks like it's 5. So that is the case. So basically that's saying the y values are different. And one more thing. If k, so just a number k, is between f of a and f of b, so let's call this k right here just a number, just a random number. So that's like right there, approximately. All right. Then what this means, then there exists a number, let's call it c, okay, between A and B. Okay, so that f of c is equal to that k value, which makes sense. So if we have a k, if I pick any k in between f of a and f of b, I picked this one. I could have picked this one. So let's call this one L if you guys want. It doesn't really matter. If there's a number here and it exists on the graph, then obviously there's an x value for that L. Okay? So if we call this D. So f of D is going to equal that L value. Because always remember that this is basically saying the inside here is your x value and this whole thing is your y value. Okay, good luck with the homework. Try it. It truly is not that difficult. Please check out those video links that I put up on iLearn. They're called video links for each section or something like that. They're very quick, like 4-minute videos for any topic that you seem to not have grasped yet. Okay, enjoy.